Hey guys, we are here. We're going to be doing lesson 52. This is for Algebra 2. Lesson 52 deals with chemical mixtures. All right, so this is chemical mixture problems type A. We're going to have two different lessons on this. We'll have one now and we'll have one again when we get to lesson 61. Okay, so what we're going to look at here is if I have two different constituents that I'm going to mix together to get a desired result. Okay, so there's going to be these things that I'm going to mix together is generally going to be water and something else. So I could have water and alcohol or water and salt or water and iodine. And in these mixtures, there's going to be some percentage of the mixture is something other than water. So I might say that I have a solution and it is 10% iodine. Okay, well, something that's 10% iodine, I've got, say, a cup of it. Well, 10% of that cup is iodine and 90% of it is water. All right, so if you're told that you have something and it is 50% iodine, okay, well, if it's 50% iodine, then it's also 50% water. All right, so say that I have 10% iodine, okay, and I have 50% iodine. All right, and what I want, so I have those two things there. I want 100 milliliters of 20% iodine. Okay, so I have 10% iodine, I have 50% iodine, and what I want to have in the end is 100 milliliters of 20% iodine. So I need to figure out what do I need to add together in order to get these things. If you wind up looking at lesson 52 in your book, they've got a picture there, okay? And they show in this picture this idea that I'm going to have, a vat, and it's got my 50% iodine in it, okay? And I've got another vat, and it has my 10% iodine in it. And I'm going to take some of this, and we're going to say that I'm going to pour some amount of this, and I'm going to dump some amount of this into this other vat that I want to have 20% iodine in, okay? All right, so that's what I'm looking to do here. So we're going to think about the fact that I'm going to have something that's going to get poured in plus something that is going to get dumped in. And when I take what I pour in plus what I dump in, I'm going to add those together and I'm going to get a total of whatever I've poured and dumped in there. Okay, so if I take it and I've got, iodine, and I pour some of this iodine in there and I dump some of that iodine in there, then I'm going to wind up with some other total of iodine. I could also look up, we think about the fact that this is 50% iodine. Well, it's also 50% water. And this over here is 10% iodine. Well, it's also 90% water. So I could either pour in my 50% iodine and my 10% iodine, or I could talk about pouring in my 50% water and dumping in my 90% water, okay? So I can look at those two things. So as we're going to look at the fact that we want to end up with 100 milliliters, right? All right, and I'm going to pour some amount and I'm going to dump some amount. So I'm going to have some amount that I pour, some amount that I dump. All right, so let's think about what I'm going to pour in and what I'm going to dump in. Well, the stuff that I'm going to pour in, the strength of it, it's going to be 0.5 is going to be what I'm going to pour in, plus this 0.1 is going to be what I dump in. All right, and then what I want to wind up getting in the end, when I'm looking at looking at considering the iodine. This is going to be 0.5 iodine poured in, 0.1 iodine dumped in, and in the end, I want to get this 0.2 of 100 milliliters. So I'm going to have 100 milliliters. Well, this 0.2 of it is going to be iodine. Okay, this should start looking kind of familiar to some of the things that we've done with rate and time. Okay, so now I'm going to take this equation right here. I'm going to rewrite this as the amount poured in is going to equal 100 minus the amount that I dump. That way I've got something that, I can plug in to this equation up here so that then I only wind up with one variable. All right, so now I have this 0.5 times, I'm going to substitute this in, 100 minus this dumped amount, okay, plus 0.1 dumped equals, and let's go ahead and multiply this out here and get that equals 20. Okay, so here we can multiply this. Here, we're going to distribute, and we're going to get 50 minus 0.5 dn plus 0.1 dn equals 20. All right, when I combine these two, I'm going to get negative 0.4 dn equals negative 30. All right, when I divide those out, I'm going to get that the amount that I'm going to dump in is going to be 75 milliliters. Okay, and this 75 milliliters is the negative 30 divided by negative 0.4 is going to give me that positive 75. Okay, milliliters is my terms. Okay, remember that the PN equals 100 minus the DN. So the PN, the amount poured, is going to be 25 milliliters. Okay, so the DN represented my 10% iodine, and the DP, the DN represented my 50%. Okay, so in order to get 100 milliliters of 20% iodine, I need 75 milliliters of 10% iodine, and I need 25 milliliters of 50% iodine. Okay? Now, with that, let's think about the fact that we could consider the water instead. So we're going to run through basically the same problem, but we're going to look at it from the other side. Okay, so where I said I had 50% iodine, that means that I also have 50% water. With the 10% iodine, that one, I have 90% water. And what I want to have is 20% iodine, which the 20% iodine is also 80% water. Okay, so again, we think about the fact that I am going to pour some amount and I'm going to dump some amount, and when I get those two things together, I'm going to end up with 100 milliliters. Okay, now this time I'm using these numbers over here. All right, so I'm going to have 0.5 for the pour, and I'm considering the water. I'm going to have 0.9 for the dump, and this is going to give me 0.8 times 100. All right, because I'm wanting 80% of that 100 milliliters to be water. Okay, so again, with this right here, PN equals 100 minus DN. And I'm going to be able to take this and substitute it in right there. So I'm going to get the 0.5 times 100 minus dn plus 0.9 dn equals 0.8 times 100. Okay? Let's go ahead and distribute those, and we're going to get 50 minus 0.5 dN plus 0.9 dN equals 80. All right, as we combine everything around, we're going to get 0.4 dN equals 30. And then the dN is going to equal 75. And again, the dP is going to equal 25. All right, and that dN was representing the 10% iodine, 90% water mixture. And the PN, oh, what did I do? Sorry, this right here should have said PN. The poured amount, okay, is going to represent the 25%. No, excuse me, represents, got my number wrong there. It represents the 50. Okay, so that represents the 50% iodine, 50% water. Okay, and that's the same thing that we wound up with before when we did the other one. Okay, the fact that the one that was 50%, we were going to have 25 milliliters. The one that was 10%, we we're going to have 75 milliliters. Okay, so we've taken the same problem and worked it either looking at the percentage of iodine or looking at the percentage of water that we're going to include. Okay, all right, let's look at another one. Okay, here we're going to consider the fact that I have two solutions. Okay, the first solution is 10% salt and 90% water. And the second solution is 2% salt. All right, so then we're going to ask how much of each do I need to get 1,400 milliliters of 6% salt. So I have two containers. One container has a solution with 10% salt, 90% water. The other one has a solution of 2% salt. Okay, this is all they're telling us in the problem, but what I can assume from this is that this is also 98% water, right? Okay, so then I've got those two containers, and now I want to pour into a third container some amount of each of these, such that I end up with 1,400 milliliters of solution, that 6% of that solution is salt. Okay, so again, we're going to go back to the idea that I am going to pour some amount, and I'm going to dump some amount, and I'm going to end up with 1,400 milliliters total when I get done pouring and dumping. And therefore, from this, I can say that the amount poured is going to equal to 1,400 minus the amount dumped. Okay? All right, let's look at creating an equation here. I'm going to deal here. I've got the, okay, so we're looking here. We've got this 10% salt solution and we've got this 2% salt solution, right? All right, so if it's 10% salt and 2% salt, then I have that it's 90% water and 98% water. Okay, so let's consider the water this time. Okay, so here we're going to call this 0.9 is what we're going to pour, plus 0.98 is what we're going to dump. And what we're going to get in the end, all right, think about this 6% salt If it's 6% salt, then it's going to be 94% water, right? Okay, so when I get these two together, I'm going to get a solution that is 0.94 of it is going to be water out of this 1,400 milliliters. Okay, so what I pour in, 90% of it's water. What I dump in, 98% of it is water. And what I get in the end, I'm going to get 1,400 milliliters, and 94% of that milliliters is going to be water. Okay, so now we're going to solve this, and we're going to take this over here, and we're going to plug it into that to this first term right here, so that I'm able to have this 0.9 times 1,400 minus dN plus 0.98 dN equals 0.94 times 1,400. Okay, so doing that math, I've got 1260 minus 0.9 dN plus 0.98 dN equals 1316. All right, combine like terms, and I get 0.08 dN equals 56, and this dN equals 700 milliliters. All right. Oh, it should have said 700. Okay, and think about the 1,400 minus the 700 is also going to give me 700. So the amount poured is also going to be 700 milliliters. So I need to do 700 milliliters of each of them. Okay? All right, guys, I will be sending you an email with your homework on it.